Hello, thank you for joining us again. My name is Kayla with Cardinal Kinetic, and this is the third tutorial in the Get Started series. Today, our goal is to make the motor spin. Start by selecting the Configure Axis block and dragging it into the initialization portion of the main program block. We can add the position hold block here as well, both from the motion categories. So we have a lot to configure here initially, starting with slots. Since we're configuring the motor on the InnoDrive that we're sending the program to, we can just choose the local slot. Any daisy-chained InnoDrives would require remote slots. Click Axes and we'll choose the motor now by clicking Create New. And my motor is this one. If you have another motor, you can select that one, or if your motor is not listed, you might need to go ahead and give us a call or email to help you out. Name the axis and continue. We'll be using sectors instead of the default millimeters, and 8 sectors per revolution. Then set the position hold to off regen. Now onto our main loop portion of the program. First, we'll add a function call block from the program category, which will always be called at the beginning of our program's loop. Then an if-else block, which we will click the little settings cog on to expand our block to fit our needs. We want it to be if-else. Let's add to the if-else block now a variable block to determine the if, and 2 motor command blocks. Alright, the function call block requires a corresponding function block that will be called when the function call block is executed from the main loop. This function will help us ensure that the motor is ready to run without faults, so we'll call it the checkMotorFaults function. This function will also include an if-else block inside. Click the settings gear to configure the if-else block to suit our needs. Once the if and if-else statement is ready, add a get flag block from the motion category and a set motor command block. The else if portion of the block will need a logical not block, and then add the get flag inside of it. Now beneath here, we will add another set motor drive block, which I'll get from duplicating the first. Let's set these all up with local slot and set up the blocks so that if the local slot has a faulted flag, it sets the local motor to clear the faults. Now, if the local motor is not enabled, enable the motor. So this function handles what to do if the motor has faults and enables the motor. But remember, this is not starting the motor, it's just getting it ready. Let's have this function report back to the main loop if it's okay to spin the motor, a clear yes or no if our motor can operate. To do this, use the green set variable block. Within this block, let's have the block and or, which works so that if both of the values within are true, then the Boolean type variable will be true. If either of these internal values are false, the variable will be false. Now, establish that variable, click the red word variable. This will launch the variable dialog box. We'll click create new, and this will be our first variable. We will name it motor OK to run. Make it API accessible, give it a Boolean type, and then set it to a default value of false. Of course, motor OK to run should probably not have a default value of true, so this just follows. Click create, and then select it for the block. So now our function is complete, and every loop checkMotorFaults will be called to ensure the motor is set up and run for the following commands. Back in our main loop, the variable block here should be configured to be the motor OK to run variable that we just created. And then we can configure our motor command blocks here beneath it. They will both refer to the local slot, as we're only working with one module, like we said before. So the first motor command block will make the motor run when the motor is okay to run, and the second one will make the motor stop when it's not okay to run. Now, the last aspect of this command is the profile, here in red. Each movement must be assigned a motion profile. Click on Profile and see the dialog box. We'll have to create a new profile here. I'm going to call our profile Smooth Jog because it's just a standard smooth jog of the motor that I'm looking for. Just to show you though how to adjust these attributes, let's click on the speed and change the value from 100% of the motor's rated speed to 50%. And then notice what else you could change if your application called for multiple profiles. Remember that we have a manual full of details on all this and all aspects really of the programmer. Once the profile is configured, you have a complete motor spinning program. You may choose to save the program or just send it right to your InnoDrive and test it out. We have additional tutorials on our website in manual and video forms, as well as a responsive support team. So if you have any questions or hit any roadblocks, please don't hesitate to contact us. Thanks so much for your time. Happy programming.